On July 1st, 2025, something extraordinary pierced through the veil of deep space and entered our solar system. The Asteroid Terrestrial Impact Last Alert System, known as ATLAS, detected an object moving through the cosmos at speeds that defied natural explanation. This was no ordinary comet. This was 3I Atlas, the third confirmed interstellar visitor to ever grace our celestial neighborhood, and its arrival would spark one of the most controversial scientific debates of our time. Hidden among the dense star fields of the galactic center, 3I Atlas had been watching, waiting, approaching. When astronomers first glimpsed its light, they noticed something immediately unsettling. This object was not following the gentle curves of gravitational physics that govern our solar system. Instead, it carved through space on a hyperbolic trajectory, a cosmic highway that spoke of origins far beyond our sun's influence. It was moving at 58 kilometers per second relative to our star, faster than any interstellar object we had ever encountered, faster than Oumuamua, faster than Borisov. This thing was in a hurry, the alignment anomaly. But speed was only the beginning of the mystery. As astronomers calculated the visitor's trajectory, they discovered something that sent chills through the scientific community. The path of 3I Atlas aligned with the ecliptic plane of our solar system to within just 5 degrees. To understand how extraordinary this is, imagine throwing a dart from across a galaxy and hitting a target the width of a human hair. The probability of such perfect alignment occurring by random chance is 0.2%. 1 in 500. This was no cosmic coincidence. The trajectory seemed almost deliberately calculated, as if the object knew exactly where it was going and when it needed to arrive. And arrive it did at a moment perfectly timed to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter. The odds of this timing occurring naturally? 0.005%, 5 in 100,000. Think about that for a moment. An object from interstellar space, traveling for potentially millions of years across the void between stars, arrives at our solar system on a path that just happens to align perfectly with our planetary plane and encounters multiple planets at optimal distances. What are we witnessing? A natural phenomenon following the chaotic laws of cosmic probability, or something else entirely? The mass paradox. As observations continued through the summer months, another anomaly emerged from the data. Using sophisticated measurements from 227 observatories around the world, scientists compared the movement of 3I Atlas against trajectories dictated purely by gravity. What they discovered challenged everything we thought we knew about interstellar visitors. The object's mass was calculated to exceed 33 billion tons. Its diameter stretched beyond 5 kilometers across. To put this in perspective, 3I Atlas is approximately 1 million times more massive than Oumuamua and 1,000 times more massive than Comet Borisov. This created what scientists call a major statistical anomaly. Given the limited reservoir of heavy elements available to form such objects in interstellar space, we should have discovered hundreds of thousands of smaller interstellar visitors before ever encountering something as massive as 3I Atlas. Yet we had only detected 2 previous interstellar objects. It was as if the universe had skipped ahead in a book, showing us the final chapter before we had read the preceding pages. The natural order of discovery had been violated. Either our understanding of interstellar object populations was fundamentally flawed, or 3I Atlas was not following the rules because it was never meant to follow them. The chemical signatures. When the Very Large Telescope and the James Webb Space Telescope turned their instruments toward 3I Atlas, they detected something that defied conventional comet composition. The spectroscopic analysis revealed abnormally high concentrations of nickel compared to iron. This ratio was orders of magnitude larger than any natural comet ever observed. In nature, nickel and iron form together in cosmic forge of stellar nucleosynthesis, typically appearing in similar proportions. But the nickel to iron ratio in 3I Atlas resembled something else entirely. It resembled the composition of industrially manufactured nickel alloys, the kind produced in advanced metallurgical processes, the kind that don't occur naturally in the frozen depths of interstellar space. Even stranger, the nickel to cyanide ratio exceeded anything seen in known comets by factors that made scientists question their instruments. When the Meerkat radio telescope detected hydroxyl radical absorption lines, the first radio signal ever received from 3I Atlas, the chemical fingerprint only deepened the mystery. This was not the signature of a typical comet. This was something different, the sunward jet. During July and August 2025, observers detected a phenomenon that violated basic principles of cometary behavior. A jet of material was streaming from 3I Atlas, but it wasn't flowing away from the sun as solar radiation pressure would dictate. Instead, it pointed toward the sun, creating what astronomers call an anti-tail. Now, anti-tails can occasionally appear as optical illusions due to perspective geometry when Earth passes through a comet's orbital plane. But detailed analysis confirmed that what we were seeing with 3I Atlas was not an illusion. This was a genuine sunward jet, a stream of material flowing in the wrong direction. The implications were staggering. What force could push material toward the sun against the overwhelming pressure of solar radiation? What mechanism could create such an inverted propulsion system? Chemical rockets achieve thrust through exhaust speeds of 3 to 5 kilometers per second. Ion thrusters push that envelope to 10 to 50 kilometers per second. These are the signatures of artificial propulsion, of technology, of engineering. The sunward jet of 3I Atlas suggested forces that did not belong to nature's playbook. The perihelion acceleration. October 29, 2025, marked a critical moment in the saga of 3I Atlas. The object reached perihelion, its closest approach to the Sun, at a distance of 1.36 astronomical units. This placed it between the orbits of Earth and Mars, conveniently hidden from Earth-based observation by the Sun itself, as if the object had planned its closest approach to occur when we couldn't watch. But we had eyes in other places. The Atacama Large Millimeter Array, one of the most sensitive radio telescope networks on Earth, tracked 3I Atlas as it rounded the sun. What they discovered sent shock waves through the astronomical community. The object was not where it was supposed to be. Gravitational calculations predicted one position. Reality showed another. 3I Atlas was 4 arcseconds away in right ascension from its forecasted trajectory. This deviation indicated non-gravitational acceleration. Something was pushing 3I Atlas, altering its course through space by forces beyond gravity. For a natural comet, such acceleration occurs through outgassing, the release of volatiles heated by solar radiation that jet away from the nucleus like tiny rocket engines. But here's where the paradox deepened. To achieve the measured acceleration through normal cometary outgassing, 3I Atlas would need to expel at least 13% of its total mass, more than 5 billion tons of material. Such a massive ejection would create a spectacular debris cloud, a blazing tail visible across millions of kilometers. Yet post-perihelion images showed no such cloud, no massive plume, no evidence of the violent mass loss required to explain its acceleration. The object had changed its trajectory without leaving the expected fingerprints. It accelerated without bleeding the mass necessary for that acceleration. This was physically impossible for a natural comet, unless it wasn't a comet at all. The color transformation. As 3I Atlas emerged from behind the sun, astronomers documented another impossibility. The object had changed color multiple times, initially appearing with a reddish hue indicative of dust-rich composition. 3I Atlas gradually shifted through the spectrum. By late October, during and after perihelion, observations from solar-facing spacecraft revealed that the object had become distinctly bluer than the sun itself. This wasn't a subtle shift. This was a dramatic transformation that violated normal cometary physics. When comets approach the sun, they typically become redder as dust scatters in their expanding comas. The material ejected from their surfaces creates clouds that filter and redden the light. But 3I Atlas was doing the opposite, shifting toward the blue end of the spectrum while simultaneously showing no evidence of the massive dust production required to cause such optical effects. Then there was the brightness anomaly. Solar observatories including Stereo, SOHO, and GOES 19 documented that 3I Atlas brightened faster than any known comet at similar distances from the sun. The intensity increased by a factor of approximately 5 in the green band wavelength range. Whatever was happening to this object as it swung past our star, it followed no natural playbook, the missing evidence. Perhaps the most damning evidence emerged not from what scientists saw, but from what they didn't see. After perihelion, when 3I Atlas should have been surrounded by a brilliant cometary tail stretching across the sky like a cosmic banner, observers found nothing. Images released by the Virtual Telescope Project and other observatories showed a compact sphere of light with no visible tail, no extended coma, no evidence of the violent outgassing that should have accompanied its measured acceleration. A natural comet experiencing the forces necessary to produce non-gravitational acceleration would be shedding material like a dying star. We should have seen clouds of gas and dust streaming away into space, backlit by the sun, creating one of the most spectacular cosmic displays visible from Earth. Instead, we saw silence, stillness, an object that had somehow changed its trajectory while leaving almost no trace of how it accomplished this feat. The Webb Space Telescope measurements from August had shown modest mass ejection rates consistent with normal cometary activity, but the acceleration measured at perihelion required mass loss rates thousands of times greater. Where was the missing mass? Where was the debris cloud that physics demanded must exist? The technological hypothesis. Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University, has put forward a hypothesis that many in the scientific community find uncomfortable. What if 3I Atlas is not a natural object? What if we are witnessing something manufactured, engineered, designed? Consider the evidence through this lens. An object arrives from interstellar space on a trajectory aligned with surgical precision to our planetary system. Its chemical composition resembles industrial alloys rather than natural cometary material. It displays non-gravitational acceleration without the expected mass loss. It emits a jet that flows in the wrong direction. Its color and brightness change in ways that defy cometary physics. Its timing brings it to close encounters with multiple planets at optimal moments. Each of these anomalies individually might be explained away as statistical outliers or measurement uncertainties. But together, they paint a picture that demands we ask uncomfortable questions. The probability of all these anomalies occurring simultaneously in a single natural object approaches zero. If 3I Atlas carries technological propulsion, even primitive rocket engines would explain the observations far better than any natural model. Chemical rockets expelling mass at 3 to 5 kilometers per second could produce the measured acceleration while jettisoning far less material than sublimating ice. Ion drives operating at 10 to 50 kilometers per second could do even better, leaving virtually no visible plume while still altering the trajectory. The sunward jet could be an attitude control thruster, a directional engine maintaining orientation or making course corrections. The color changes could reflect different operational modes, different materials being expelled, or different surfaces being exposed as the object rotates and activates various systems. The perfect alignment with our ecliptic plane would not be coincidence but design, the calculated approach vector of a craft that knows where it's going. The December window. As November 2025 draws to a close, 3I Atlas races toward Earth, not for collision, but for passage. On December 19th, it will make its closest approach to our planet, sweeping past at a distance of 1.8 astronomical units, approximately 270 million kilometers. This is our window, our opportunity to gather the data that will finally answer the questions that have haunted us since July. The James Webb Space Telescope has been tasked with spectroscopic analysis of any debris cloud or gas plume surrounding 3IATLAS. If the object is a natural comet, the missing mass ejected during perihelion must still be there, dispersed around the nucleus, carrying chemical signatures that will confirm its ordinary nature. But if no such cloud is found, if the space around 3I Atlas remains clear and empty, then the non-gravitational acceleration measured at perihelion will stand as evidence of propulsion from a source other than cometary outgassing. Ground-based observatories around the world have coordinated observation campaigns. Radio telescopes will probe for signals, intentional or incidental, emanating from the object. Optical instruments will track its continued evolution, watching for more color changes, brightness variations, or trajectory adjustments. Every piece of data collected will either narrow the possibilities or expand the mystery further. This is not the time for assumptions or comfortable conclusions. This is the time for rigorous observation, for following the data wherever it leads, for maintaining the scientific humility to admit when something doesn't fit our models. The universe has delivered a puzzle to our doorstep. The question is whether we have the courage to solve it. The dimensional hypothesis. But what if the explanation goes beyond simple technology? What if 3IATLAS represents something even more profound? Some theoretical physicists have begun to whisper about possibilities that sound like science fiction, but emerge from rigorous mathematics. Our universe may not be the only one. The equations of quantum mechanics and general relativity, when pushed to their extremes, allow for the existence of higher dimensions, parallel realities, alternate universes separated from ours by membranes thinner than the concept of distance itself. What if 3I Atlas is not just an interstellar visitor, but an interdimensional one? Such an object would display exactly the anomalies we've observed. Its trajectory would appear to violate conservation laws because it would be drawing energy from dimensions we cannot see. Its composition would seem unnatural because it would be assembled from matter that obeys different fundamental constants. Its propulsion would work through physics we haven't discovered because those physics operate in spaces we cannot access. The alignment with our ecliptic plane might not be targeting our planets, but targeting something else, some confluence of dimensional barriers that makes our solar system a crossing point between realities. The arrival timing might correlate not with our planetary orbits, but with cycles of dimensional permeability, windows that open and close according to laws written in mathematics we haven't yet learned to speak. This hypothesis sounds fantastical. But remember that a century ago, the idea of black holes, of quantum entanglement, of the expanding universe itself, all sounded equally impossible. Science advances by taking the data seriously, even when the data points toward conclusions that challenge every assumption we hold dear. The warning: if 3I Atlas is technology, if it represents intentional design, then we must face the most profound question in human history. Why is it here? The object's trajectory brings it near but not dangerously close to Earth. It's not on a collision course. It's not behaving aggressively. But its path does take it past Mars, Venus, and Jupiter at distances that would be ideal for what? Observation? Resource gathering? Deployment of smaller probes? Dr. Loeb has suggested a disturbing possibility. What if 3I Atlas is a mothership? What if its retrograde motion and perfect timing allow it to release smaller craft that could drift into planetary orbits as those planets pass through the deployment zone? The retrograde trajectory would be optimal for such a maneuver, allowing released objects to match orbital velocities with minimal energy expenditure. We would never see the smaller probes. They could be the size of toasters, of smartphones, of dust grains. Current detection systems are optimized for large objects on predictable paths. Something small, dark, and maneuvering could slip past our sensors like ghosts through walls. By the time we realized they were there, they could already be in orbit around Earth, Mars, or any other target they were designed to reach.